Hi Rockridge, this is Mrs. Berger, and today I'm going to go through Unit 4 Day 2 notes, and I'm going to split this into 3 videos. So this is the first video, so we'll call this Unit 4 Day 2a, just to make these a little more consumable videos. This goes along with the book chapter 4.4, okay? What I want to start off today's lesson with is sort of a lead-in from the quiz we just took, okay? So let's take a look at the sentence I've written up here, handwriting here. In a class of 26 kids, there are 18 athletes, 13 males, and 10 male athletes. And some folks, when you took the quiz recently, you said, hold up, Mrs. Berger, 18 plus 13 plus 10, that's more than 26. I think you made a mistake there. Remember, we can have, for these two events, since it's not mutually exclusive to be an athlete or a male, you can be both. Because of that, you've got some layover, right? You've got some crossover in that. So when you were to make your two-way table, and on the quiz, obviously, it wasn't males and athletes, it was two different topics, but this was the type of information you were given. You need to back into the two-way table by saying, okay, I know for a fact that there are 26 total people in the class. I know for a fact that 10 of them were both male and athletes. So male and athlete. I know for a fact that there are 18 total athletes. So athletes being yes, totals 18. And I know for a fact that there were 13 total males. So there were 13 total males. So those pieces of information need to be permanently entered into your two-way table. Everything else from here is just backing into whatever the subtraction leads you to believe for the rest of the numbers. Okay, you need to leave the blue. The given data should not ever change. If you make a math error, don't erase the given blue information. So at this point, we just need to back into the other information. We know how two-way tables work. You add down and you add up to the right. So you add things to be total. So if we have a total of 13 males and 10 of them are already in the yes athletes, that means we must have 3 non-athlete males. If we have 26 total students and 13 of them are male, there must be 13 female. If we have 26 total students and 18 of them were athletes, that must mean we have 8 of them that are not athletes. If we have 18 total athletes and 10 of them are male, that must mean 8 of them are female. And if we have 8 total non-athletes and 3 of them are male, that must mean 5 of them are female. Okay? And you could have filled that in a different order than I did. But that's the type of work that we want to do. We want to put the given information in there and then back into the rest. Now, once we have that two-way table, we can now go ahead and create a Venn diagram with that information. Now, this was another tricky part. Some folks made one circle for male and another circle for female. That's not how Venn diagrams work. You need to intersect the male-female circle, you're either male or not male, with a circle that is athlete or not athlete. Okay? Athlete or not athlete. So male and athlete, you could have chosen female and not athlete, but male and athlete, those are the circles that are intersecting. And of course the intersection, the middle, the crossover point, the intersection of male and athlete is 10. The part that goes in the male circle that is not in the crossover, those are males that are not athletes. So a lot of folks accidentally or mistakenly put that there were 13 males. That's true, there are 13 total males in the room, but we've already accounted for 10 of them. So the 3 that go here, those are the males that, yes, they're male, but they are not athletes. Okay? And then for the athlete circle, if you are an athlete and a male, you've already been accounted for in the middle here. So now we need to account for the remaining athletes that are not male, or the athletes that are female. Okay, so that's what goes in the athlete. And then remember that there's a possibility that you have a set number of people that are neither male nor athlete. That can be found here. Neither male nor athlete, that's outside of both circles. So hopefully you see that when you're looking at a two-way table, to make that transform into a Venn diagram, you're going to be using these middle four values. Those four things will be represented in your Venn diagram. Don't be representing your totals. Okay, this total of 26 should be what your Venn diagram items add up to. Okay. All right, so that will flow us right on into our lesson for today. So we have been doing probabilities up to this point, and that's probabilities of selecting a male out of the entire class. Now we're going to be talking about things called conditional probabilities. And if you did your homework, you looked up that, you read this chapter 4.4, and you read the definition of conditional probabilities. Let me show you an example of a conditional probability. If you were to ask to calculate the probability of randomly selecting a classmate who is male, given he's an athlete, that's a conditional probability. So we're asking, what is the probability of randomly selecting a male with the condition that you have a subset of athletes? So it's like you walked in the room and you divvied up the room first. Before you went any further, you said, all right, before I randomly select somebody, everybody get into males and everybody get into females. Let me show you the notation. Probability of randomly selecting a male given he's an athlete. That's the notation for given. And just as a recall, right, we had, this is the probability of a male and an athlete. Okay, that's and. This is probability of selecting a male or an athlete. That's or. And now we have this new one, given. Okay, this nice bar right here, that's given. Selecting a male given they're an athlete. The way we do this, selecting a male given they're an athlete, I like to start with a denominator. I like to know sort of what portion of people I'm looking at in the first place. So I like to say, all right, if I'm subjecting myself to only the athletes, that must mean I'm looking at the total athletes in the room first and foremost. And there, in our particular room that we're looking at here, there are 18 athletes. So given he's an athlete, that means I'm looking at 18 people total. And within those 18 people, 10 of them are male. Okay, so the probability of selecting a classmate who is male, given you're only looking at the athletes, that's how you calculate that. Okay, and that goes down, I think that's about 55%, if you were to put that into decimal form. Now let's compare that to the next question, which looks really similar but is different. Now we're going to calculate the probability of somebody who is an athlete given they are male. So the notation, of course, for that is probability of selecting an athlete given they are male. Once again, I like to work on the bottom of the fraction first. Given that we're looking at only the males, that means that's the denominator. The denominator of total males in the room to begin with, that was 13 people. There were 13 people in the room. So given that they are male, you're looking at 13 people. And out of those 13 people, the athletes in that category, the athletes, was 10. And I think if you do the math on that, I think it's somewhere around 77%. Okay. So if we were to compare those two, which again, they sound very similar in English, right? Selecting a male given he's an athlete, selecting an athlete given he's a male. They sound very similar, but they're different. The more likely probability is the probability of selecting an athlete given that they are a male, right? Because this was around 77%. And I think this one was somewhere around like 56 or 55%. The probability of selecting an athlete given they are male. That is more probable in our particular scenario. Okay? Now, how are we going to tell if two events are dependent or independent just by looking at a two-way table? And if you had read the chapter, hopefully you saw a little bit of this notation. If you want to know if somebody is, or if two events are dependent or independent, here's what you'll need to do. Let me clear some room here. Alright, so sorry about the messiness of this, but let's just focus on how can you tell if two events are dependent or independent. Here's how you tell. If the probability of event A happening given event B has happened is equal to the probability of A happening, the events are independent. Okay, so we need to compare those values. Compare this, what this value is, and what this value is. Or, if the probability of B happening given A happened is equal to the probability of B happening, you're independent. Oops. You're independent. Okay, you've got two independent events. Because the probability of A happening is the same whether B happened or not. And the probability of B happening is the same whether A happened or not. If at any point these are not equal, that means you've got dependent events. That means when A and B happen together, it has an impact on the probability. Okay? It has an impact on the probability. So, if these two statements, if one or both of these are statements are true, you've got independent events. So to answer our original question, how can you tell if two events are dependent or independent just by looking at a two-way table? Well, if you've got that two-way table available to you, you can calculate P of A given B, figure out what that probability is, and then say, hey, is that equal to the probability of A just happening overall in the whole wide room? If they are, if they're the same, then those events are independent. Whether you subdivide your room into just the B people and choose A, or you take the whole room and choose A, it's completely independent of each other. But if those are different, then those events are not independent of one another. Okay, those are dependent events. Let's take a look at two examples. I'm not going to do all of the examples that you have on your practice sheet. I do want to do a couple with you though. So let's take a look at question number 1. Random sample of 452 high school students were surveyed. And we've got results here of, we've got females and males. And they measured, and so we're going to call that the probability of selecting a female, the probability of selecting a male. And they compared which finger was longer, the index finger, the ring finger, or if they were the same length. And so we'll say, we'll call that I, R, and S for same length. So the first thing we need to do is figure out what they're asking us to find here. So we need to translate that. So take a moment to think about how you would translate that statement. Hopefully you thought to yourself, all right, they want me to find the probability of someone having a longer ring finger given they were female. Okay? So from the two-way table, you should be able, or from the table, it's not two ways, but from the table, you should be able to see that the probability of someone having a longer ring finger given they are female means the subset of people we're looking at are just the females, so that's 212 people. And out of those 212, that subset, how many of them have longer ring fingers? 82. Okay. So that number, that probability, obviously you can do the calculation of 82 divided by 212. When you get that probability, as you know, on tests and quizzes, I hardly ever ask you to just spit back a number, right? I don't need you to just spit back 0.387 at me. I need you to interpret that value. So to do that, you'll say the probability of randomly selecting let's call it someone with a longer ring finger given they are female is 38.7%. Okay, so on a quiz or test, if I ask you to calculate or find P of R given F, you'll do that, and then of course I'll follow up with, can you please interpret that value in context? And that's the type of sentence I would be looking for. So let's look at part B. Given that the chosen student does not have a longer ring finger, what's the probability that this person is male? So first I want you to write it symbolically and then find the probability. I want you to try that before I give you the results. So if you want, go ahead and pause the video. Try to write that symbolically first of all. Hopefully you've had a minute to attempt that symbolically. What you should have come up with was the probability of getting a male given that that person does not have a longer ring finger, right? So R, the not R, the complement of R, someone not having a longer ring finger, is the given, right? So given they do not have a longer ring finger, given they don't have a longer ring finger, what's the probability that the person is male? Okay, so probability the person is male given that the complement of the ring finger, they do not have a longer ring finger. So that's what it is symbolically. Now we're going to find the probability. So like I said, I always like starting with the denominator. It just makes more sense to me. The subset of people we're looking at are the people that don't have a longer ring finger. So the total people that don't have a longer ring finger is found here and here, right? 123 plus 95 are the total people who do not have a longer ring finger. So given that those are the subset of people we're looking at in the room, where are the males in that scenario? Here are some of them, and here are some of them. So 45 plus 43. Okay? Obviously, you guys know how to plug stuff into the calculator, so the next few steps aren't anywhere near as important as coming up with what you're being asked in the problem. So concentrate on that part. I know you can plug things into a calculator, right? So 88 divided by 218. I know you know how to do this part. It's getting to this part that I want you to focus on. Okay. So that's 40%. Alright, so hopefully you feel pretty comfortable with those. Pause and replay if you need to. Let's take a look at number 2 together as well. A random sample of 500 U.S. adults was selected. Each member was described as either being a high school graduate, that's G, and being a homeowner, that's H. Some people were both, some people were only one, some people were only the other, and some people were neither. Okay, so that's what's showing in the Venn diagram. Now, I don't love the phrasing of this question, and we are going to try our best to phrase these a little better on quizzes and tests. But what it's trying to ask you in this question is, what is the probability of selecting a graduate given they own a home? Okay. So my apologies for how this is phrased. What's the probability that a randomly selected person who owns a home is also a high school graduate? That's not always the clearest way. So you should read that statement as, what is the probability of selecting a graduate given they own a home? So symbolically, that looks like this: probability of getting a graduate given they own a home. You should know that the bottom of that fraction is the probability of having people who own a home. And from the Venn diagram, that's the blue circle. That's everything encompassed by the blue circle. So that's the 221 that's in the crossover, as well as the 119 that's only in the blue. So that's our denominator. That's our subset of people, the people who own a home. And out of those people who own a home, obviously, those that are graduates are the 221, that's the crossover. Okay. And so we can do the math on the calculator for this. Pulling the data off the Venn diagram, obviously, is what I want you to get at most importantly. I know you know how to enter things into calculators. 0.65 or 65%. if that made sense to you, if you were able to read the problem, understand how to come up with the symbolism, and then pull the data off the Venn diagram, I am thrilled, and I would love for you to go ahead and move forward. If you would like to get some of the more math terminology from this, or have something to have in your mind when you're doing these, let me show you that to calculate P of G given H, what we did, how we pulled those numbers, the numerator was P of G and H, and the denominator was P of all of H. Okay? And of course you can replace that with A's and B's for a generic formula to memorize. But when you're looking at conditional probability, that's the formula that you're using. We used that formula without even knowing that we were using it when we pulled data off the Venn diagram, and when we pulled data out of the two-way tables, or the tables with the left and with the middle finger and the ring finger. This formula, if it helps, I want you to use it. If it doesn't help, if you intuitively get the information off the Venn diagram and the tables, I'd rather you do that. Okay? So now go ahead and try questions number 3 and 4, and go ahead and come see us if you have questions. Let us know if you get stuck on those, and I'll go ahead and make the other videos separately.